You walk into a restaurant, bored with your usual orders. You have too many options. You either get frustrated or you ask for recommendations. Now imagine if the restaurant keeps records of customers' ratings. What they liked, what they disliked, the type of meat they prefer, and even their taste in food. Then the chances are you will get a meal you like maybe 90% of the time. Hi, this is Sham, an Android and Java developer. And just like this restaurant, I'm going to simulate how real recommendation systems work, like Netflix, Amazon, and YouTube. Let's get started. In the last episode, we had an overview of the system I built to visualize the logic behind recommendation systems. Today, we will go deeper and see how movies are filtered. From millions of movies, how does the system actually decide what to recommend to you? I used item-based collaborative filtering, where we use users' ratings to compute similarities between items. It worked, but the results were wrong. I had duplicate similarity rows, weird similarity scores, and genre conflicts. Let me show you how I fixed all of that. For each movie you rate, a function is triggered. This function takes the ID of the movie you just rated. We will call it movie A. The function works as follows. First, we build a table that maps all users who rated movie A and their ratings. Then, using the same users, we build another map for candidate movies. These are other movies rated by the same users. After that, we compute the similarity between movie A and each candidate movie B, using cosine similarity. This is the core function of item-based collaborative filtering. Cosine similarity measures how similar two movies are by dividing the sum of the multiplication of ratings for movie A and movie B by the multiplication of the square roots of the sum of squared ratings for each movie. Everything seemed fine. But then came my first big mistake, duplicate similarities. For example, Toy Story was compared with Tinkerbell movie. And then Tinkerbell was compared again with Toy Story. Same comparison, same meaning, but saved twice. I fixed this by enforcing constraints. So the system only saves the pair once, regardless of the order. The second mistake was related to genres. I was only using user ratings. That means if user A rated an action movie, the system could recommend a movie highly rated by other users, even if it was pure drama. That doesn't feel right, so I introduced genre similarity using Jaccard similarity. Jaccard similarity is a statistical measure that calculates how similar two sets are by dividing the size of their intersection, shared genres, by the size of their union, total genres. Now similarity is based on user behavior and movie content. We will walk through the compute similarity function inside the recommendation service of my Spring Boot project. You can find the full code on my GitHub, link in the bio. We will also use Postman to send rating DTOs and see how movie similarities are calculated in real time. It all begins when a user submits a rating for a movie A. Movie controller triggers the rating service, which call compute similarity function, the master of the filtering. It consists of four main phases. Phase 1. Build the reference rating map. The first thing the function does is collect all ratings for movie A. We build a map like this: key for user ID, value for rating given to movie A. This gives us a clear picture of who rated movie A. If movie A has no ratings, the function stops, because similarity without data is meaningless. Phase 2. Find candidate movies. Next, we take all users who rated movie A and fetch every other movie they have rated. This is important. We don't compare movie A with all movies in the system, only movies that share at least one common user. For this small dataset I have, we group those ratings into another structure movie BID, map of user ID and ratings. This creates a list of candidate movies that are worth comparing. Phase 3. Compute similarities. Now comes the core logic. For every candidate movie B, we find the common users between movie A and movie B. Only users who rated both movies are considered. If the number of common users is below a minimum threshold, we skip this movie. The data is too weak. We compute rating similarity using cosine similarity. This measures how aligned users' opinions are between movie A and movie B. If users rated both movies similarity, the cosine score gets closer to 1. Then we compute genre similarity. Each movie has a set of genres. Using Jaccard similarity, we measure how much those genres overlap. This prevents recommending movies that are numerically similar but semantically unrelated. Finally, we combine both scores. For example, 70% for rating similarity and 30% for genre similarity. This gives us a final similarity score that reflects both user behavior and movie content. The final phase, phase 4, persist similarity safely. Before saving, we normalize the movie pair. Smaller movie ID for movie X and large movie ID for movie Y. This guarantees no duplicate pairs, no reversed comparisons. We then insert the similarity into the database. If the pair already exists, it's updated. If not, it's inserted. Why this flow works better than my older one? This design ensures that similarities are computed incrementally, results stay consistent, and recommendations scale with user activity. Each new rating refines the recommendation graph instead of recalculating everything from scratch. If you send the ratings DTO list to the service, you can then see the similarity table and its SIMS values. So how to recommend actual movies ID? The service doesn't just return similarity calculations, its main job is to recommend movies. This is what we will discuss in the next video. If you find this helpful, subscribe for more. And remember, to make this, I started with more simple, messy solutions. It's just data, math, and clean backend design. See you in the next time.